This case study is about some work we've carried out last year on Heathrow Airport. So in Heathrow Airport, the Terminal 3 arrival building is due to have an additional number of stories on top of it. So the aim of the work was to basically increase the amount of bearing capacity under the foundations to accommodate for that increase in the number of stories. Now, originally, the foundations of the building was designed to have an allowable bearing capacity of 160 kVA, and adding an additional story will mean that this allowable bearing capacity will not be sufficient. So, and it needs to be increased by almost double the amount to accommodate for the additional 2 stories. Now, to do this, there are 2 options. It's either via you can achieve this increase in bearing capacity by altering the existing foundations, so making the foundations bigger and increasing the footprint of the foundations, or alternatively increasing the strength of the soil by means of ground stabilization. Now, the work basically there's about 14 pads that required treatment. Pad foundations, and if you want to do it the conventional way, this will involve, or by increasing the footprint of the foundations, it will require excavating to the foundations and putting a lot of temporary works, and all of that will lead to major disruption to the operations of that terminal building. Okay. Therefore, alternatively, a geopolymer injection design was proposed to strengthen the soil, and while keeping the building at keeping that building operational without any major disruptions. And what we proposed was to inject the soil below the foundations via drilling outside the building. So we were standing outside the building, drilling at an inclined angle through the foundations and through the pads of the foundations, and injected below those foundations from the outside. And we were required to almost increase the bearing capacity by up to 100% on certain pads. And we were not allowed to introduce any kind of lifting, so no lifting was permitted during the injections. And we used a highly expansive polymer to compact and improve the ground below the foundations. Now, for us to understand what sort of improvements we've achieved, we've carried out extensive modeling. And that extensive modeling showed us that we basically, with the injection and the treatment, we'll be able to accommodate a higher foundation loads, with maintaining an acceptable factor of safety and acceptable settlement limits. Now, we've carried out the design for it. So every pad received a special, unique treatment. So every pad had a unique design, a bespoke design, because every pad had a different depth, different soil conditions underneath. But when we carried out the work, we've done pre and post dynamic probing to verify the level of improvement achieved on every single pad. And this is the results that you can see here on this table, where it shows the amount of polymer that we've injected versus what sort of level of improvement in the SPT blow count and in the modulus of stiffness of the soil below the foundations. And you can see in some instances we managed to increase the bearing capacity by up to 370%. Now you can see that the level of improvement varies between different pads, and this is because there were different load requirements on every pad. So the level of improvement that we needed to achieve basically varied from one position to an adjacent position. We've managed to complete the work in line with the program, with minimum disruption to the operation of the terminal.